We're on.
Brent, I'm going to have you lead the intro because
No,
I
you lead
my audio here, and now I'm having some issues. Brent, take it away.
All right. Welcome to Containers from the Couch. If you've never joined this audio stream, a special welcome to you. We try and stream every Monday through Thursday. And we just try and tackle whatever container topics we find it interesting. We definitely take requests over Twitter. So, by the way, our Twitter handles are right here. So please tweet and follow us. We try and keep it low volume and container related. I might have an occasional barbecue tweet, but that's just me. So join us every Monday through Thursday. Now, that said, tomorrow is a special day. Adam, you want to talk about that?
Yes, good timing. I fixed my everything, so we're good. So tomorrow is our first cloud containers conference. Is that right? C3 we call it.
I only call it C3, so I actually have no idea. But yeah, Cloud Containers Conference.
Yes, and so it's actually, this is our first ever virtual Cloud Containers Conference. So I think it's going to be really cool. Brent, could you pull it up on the screen? Yes, thank you. So we're going to have a keynote, which the GM of our EKS service, Bob Weiss, will be giving the keynote. And then we're going to be doing some sessions on some different topics. So definitely check it out. It's good. We're going to go over EKS, talk about Fargate, persistent storage, as well as just really anything that's kind of hot right now in the containers world on AWS. So I'm sure we'll have some really cool announcements. So always be tuned to that. Yours truly will be doing a deep dive on ECS capacity providers. That's me. And then, nice. And then Brent and I are actually going to do some Q&A. So we're not going to be doing containers from the couch tomorrow in our traditional way that we've been doing it the past couple of weeks. We're going to instead be doing it as a Q&A session live, where we'll be answering questions and, just kind of throw them our way, and we're going to do our best to answer them.
Exactly. So that'll be coming up tomorrow at a slightly adjusted time. Actually, is it on the agenda here? I don't see it on the agenda. Plan on about, what time did I say? 12:25 Pacific time is kind of what we're aiming for a live Q&A session. And we're going to get, Adam, will you join tomorrow?
Will I join?
Yes.
Of course.
I'll just say, yeah, Adam will be there. I'll be there. We might bring on one or two others. So we're just going to be here to field all your questions. So definitely have some ready to go. Hopefully some of the sessions before that will actually even maybe inspire some questions. So yeah, definitely check that out. Sign up if you missed the link. It is, where did I put it? Right there. So definitely go there, sign up, add it to your calendar, and then we'll be right here live on Twitch all day. So twitch.tv/AWS. And then the Q&A session with Adam and me, Containers from the Couch Special Edition, is going to be 12:25-ish, whenever we can fit it in. So yeah.
Yes. Now, that's really cool, and that's going to be that'll be an action-packed, fun day. Now, as for today, and let's rein it back in. We're going to talk about. I would say, I'm just going to be honest here, my favorite technology on the containers team, because if there's one thing I don't like managing, it's servers. And it's not a knock on managing servers. It's just my personal preference. Being as a person that's come from, my background's in DevOps. I've worked on DevOps teams, operations. Always the pain point was trying to troubleshoot something that's going wrong on an EC2 instance, or something in my with my orchestrator, what's going on in the data plane. So today we're going to talk about Fargate, and we're going to talk about Fargate on EKS, and Brent is going to walk us through deploying Fargate on EKS. So it should be fun, should be exciting.
I hope. I mean, I always hope that there's, learning opportunities in these demos, but at the same time, I really hope that it goes well. So that's the number one hope, and we'll just talk through it. So if this is your first time joining us, then maybe you aren't quite familiar, but when we talk about EKS and when we talk about ECS, a lot of times we do it from the context of one of the workshops. So we have 2 workshops that you can work your way through. So today we're going to be talking through a portion of EKS workshop. And you can find this, by the way, at eksworkshop.com. And then we're in the beginner section, and we're going to take a look at the chapter Deploying Microservices to EKS Fargate.
And one thing is if you've seen our stream, or if you haven't, we have recorded videos of our streams from the past few weeks we've been doing this. So as Brent said, we go through different aspects of the 2 different workshops, ECS workshop, EKS workshop. So if there's something that you look in the videos, watch the videos on your own pace, but you'll see we'll walk through the workshops there as well. So
totally. By the way, I'm not offended. I like watching my videos at 1.5x because apparently I talk slow. I don't even realize it as I'm talking, but yeah. So watch it at 1.5x. It's actually pretty cool. Okay, so what is Fargate? Fargate's kind of a funny thing to talk about because, normally we're talking about orchestrators. And, in context of deploying, a lot of times what you're talking about is what steps you have to go through when deploying to your particular orchestrator, in our case, EKS. But Fargate isn't an orchestrator. It's a managed data plane. It's a managed compute platform. So we would talk about it in very similar ways to how we talk about EC2, right? So instead of have EKS launch your containers out onto EC2, we're talking about having EKS launch containers out onto Fargate. So why use Fargate? What advantages does it offer over using EC2?
Was that towards me? Because I love answering.
I think it was. Yeah.
All right.
Go for it.
Well, I think there's a multitude of reasons, but let's start kind of basic. One is I don't have to provision or manage or patch EC2 instances. I don't have to think about that. And regardless, if you're running EC2 instances, you have to think about those things. I have to think about patching them, making sure they're up to date, controlling access to those EC2 instances. Brent, one thing you and I are passionate about is when I build something, I don't want anyone, like when we have our environment up and running, I don't want people SSHing in because when humans go in, it's in our nature, whether we intend to or not, we make mistakes and we can break things and we can cause problems.
Yes. No humans should be doing things. Just no humans do. Only maybe observe, but even that's sketchy. So no SSH was always my starting position.
And so by moving to Fargate, we are already eliminating that piece from a security perspective and from a management perspective. The other thing that I want to mention is scaling. And you've heard me talk about this before, but when you have to scale, there's 2 places you have to consider scaling when you're managing your own EC2 instances as your worker fleet. You have to scale EC2 to meet the demand of your pods, right? So as my pods scale out, I need to make sure my underlying EC2 hosts scale out. With Fargate, I don't think about that.
Yeah, that's pretty awesome. There's also just the idea that you're paying for the exact value that you're asking for. Like when you're loading containers onto EC2, and then you have to scale out your next EC2 instance to get more capacity, then there's a lot of excess that's left over, and you're paying for that excess. But when it comes time to launch a container on a Fargate, you specify the container size that you need, and that's exactly what you end up paying for. So your sort of dollars to resources mapping is a lot tighter. There's not really excess. And then automated high availability is the other thing. Just you launch out onto Fargate, and your stuff is going to be resilient, and any failures that happen below your container level, we'll take care of. We'll handle all of that for you. All of that operational overhead just goes away. So you get to focus on just the parts that are in your container. And once it's up and running, then that's all that really matters.
Yeah. And is it fair to say, this is kind of like a serverless way of running containers, right?
It is 100% fair. These are serverless containers, and we're going to actually we're going to try and do that. So we're going to launch an application, and if you joined us yesterday, you saw us launch the 2048 game. We were showing off ALB. So we're going to do that again today, but this time we're going to launch it out onto Fargate. And we're going to talk through the differences and the similarities to what we did yesterday. So one prerequisite to note is Fargate data plane is available in only certain regions. It's many regions though, so definitely check that out and just be ready for finding your region. So what we're going to do next, we have to figure out a way to map or tell EKS this set of compute should run on Fargate versus a different pod definition or something like that running on our managed worker nodes or our own self-managed worker nodes. So the way we do that is by creating a Fargate profile. Now, a Fargate profile is a really simple idea, and that's really just a way of mapping everything in a particular namespace, or you can even carve it up further and you can say everything that matches a certain set of labels in a particular namespace should be launched out onto Fargate. But what's cool about that is we don't have to go through and modify our pod definitions to do that. So yesterday we launched the 2048 game, and today we're going to use the exact same pod definitions. We're going to launch it again, but because we're doing it after using this Fargate profile, it's going to run on Fargate. So let's get started. So I have my cluster from yesterday. And by the way, if you're just starting out new and you haven't built the cluster, definitely step through the build process in the workshop, follow along with those steps. And that's really the only prerequisite for this particular chapter. Everything after the building chapter is just unnecessary. You can skip straight to this if you want to.
Hey, Brent, I wanted to just interrupt really quick before we dive even deeper into this. I think something that we should talk about is if you're familiar already with EKS, there's the concept of managing your own worker nodes. Then there's the concept of using managed worker nodes. And then there's the concept of Fargate. So maybe a quick explanation. I know we've done it in previous streams, but maybe a quick overview of the kind of the three ways to run your pods on EKS, and that would probably be helpful.
Yeah, good call. So like you pointed out, there's bring your own EC2 instances. And at that point, you're managing the AMIs, you're building them yourself, you're making sure that all the necessary software is installed on them. We also then provide an AMI at that level if you want to use one of our provided AMIs, but it's still then under your management, so you can add to it, enhance it, and do whatever you need to with it. Then there's the next level up of abstraction, which is us managing the worker nodes for you, and we call that managed worker nodes. And in fact, the cluster that we build, if we look at our config, we actually build a managed node group. So this managed node group, what's the difference? Well, again, we're providing the AMI, we're constantly patching it and updating it, and we're putting the software that is necessary to run on it. And we'll be able to help with the management of those nodes. So we can add to the nodes, we can reboot or delete the nodes. We're basically giving the EKS control plane permission to operate on those nodes. So that's really the biggest difference, is there's no permission when it's self-managed, when it's bring your own EC2. But when it's a managed node group, then the EKS control plane and the EKS service has permission to do things to those nodes, all in support of making things better, all in support of patching and upgrading and stuff like that. So I think someone in chat agrees. Managed worker nodes are probably the best named thing on AWS. Yeah,
I don't know if that's a dig at how we name services. I'm not sure, but
it might be. It's super easy to understand what we're talking about. I'll give you that. So then the third layer, or the third level, is Fargate. And so Fargate is just get rid of the nodes, just run my containers. And that has some really, really cool side effects insofar as I don't ever have to worry about upgrading any operating system. I don't ever have to worry about when I upgrade platform versions or any of that. On my next deploy, I'm just going to get whatever the latest happens to be. So it's really cool when you start to think about all the stuff that goes away from having to manage your instances or even your managed nodes. Like, that just goes away from the equation altogether. Adam, you and I have worked together long enough. You know how much I love to delete code. Deleting code gets me more excited than adding code. And absolutely. I feel the same way here. I love deleting infrastructure. So as long as I can get rid of infrastructure and replace it with something that is going to be as good or better and definitely easier, that's what I'm going for. So Fargate allows me to do that. I can get rid of a lot of EC2 instances that normally I have to pay attention to, and that's just less for me to have to worry about.
Yep, and yes, I will confirm that you do like to delete infrastructure and code. This is true, whether you like it or not. Brent, I support this, by the way. But yes, I agree. I concur. You are a fan of removing infrastructure, and as
absolutely.
am
I. Absolutely. Okay, so let's take a look at our starting point here. We have 3 managed nodes. This is the typical cluster that we build in the workshop. It's a really good starting point, and you can see that they've been up for a couple of days now. So this is the same cluster that we used yesterday, and I think I built it yesterday, maybe day before, I can't remember. Anyway, very, very normal stuff. Let's take a look. I want to show you the before and after in the console also. So this is my cluster in the console, and let me do a quick refresh. And you can see that, normally when you come into the EKS console, well, I'll just walk you through the front door. So this is the landing page, and you can click on clusters, and you see all of my clusters. I have one. And let's go ahead and take a look at that one. And you see the details. It was created creation time, and I see my IAM role ARN, cluster ARN, the KMS key that it was built with, because I like enabling secrets encryption. That'll be a topic for another day. I'm really looking forward to talking that through. And then let's look at the compute level. So this is when it comes time to launch a container, what options do I have? And right now I have 1 managed node group. It's called node group, and its desired size is 3, and the current AMI release version that we're working with is listed here. I don't have any Fargate profiles. So right now my cluster is not capable of launching stuff out onto Fargate. So let's fix that. Okay, what we want to do first is create a Fargate profile. So I'm going to paste this because it takes a couple minutes, and then we're going to talk about it. So EKS control, create Fargate profile. Now, I could have done this in the console. There are other code ways to do this, but I love using EKS control. And this is a super simple way to just have it do everything in a best practices sort of way. The options that I'm passing, cluster and the name, EKS workshop, EKS control, then name is 2048 game. That's the name of the Fargate profile. And it could really be anything, but you do want to make it something that you're going to recognize in a few weeks or a few months, because there might come a day when you want to consider deleting it, replacing it with something else, and you want to make sure that you're picking the right one. And then the selector is namespace 2048 game. So what I'm doing here is I'm basically building a profile that is telling the EKS control plane anything that comes up in the namespace 2048 game that is compatible with Fargate, launch it out onto the Fargate platform. So that's what it's going to do for me. And again, this is going to take a few minutes. So let's check the console and see if we can already see a little bit of progress. Cool. So yeah, it shows that it's creating, and there's the profile name. Notice the subnets that it's coming up. Like, I didn't have to pick the subnets. It knows which subnets to pick, and it just took care of doing that for me. Let's explore what the subnets are.
And the console has come such a long way. It's so nice that you can do this all in the console. You have visibility into this, into all your node groups, your Fargate profiles, all from the console. It's just super clean, and it's grown a lot. The experience, the user experience from when, day one when we released EKS.
Yep, exactly. Day one was very much just a, get it out there and make it usable. But then we just start iterating on it, and we start enhancing it, and now when you look at it, it's pretty great. Okay, so what I wanted to point out here is the three subnets that the Fargate profile is going to be using and going to be attached to. They're the three private subnets. So that's one requirement that you're going to have, is that if you're wanting to build and use Fargate on your EKS cluster, make sure that you built it and built your VPC to include private subnets. If you have only public subnets, you might have to go back and sort of reconstruct your VPC, or add, hopefully you still have some IP space and you can add some additional subnets to it. So by the way, I'm looking at to notate that it's private, among other things. There's a few places to see this, but I see that I'm attaching to the private route table. So that tells me, and same for this availability zone and for our third availability zone. So we're using the three private subnets, and we're not using the three public subnets. We can also explore this. Well, let me just open a new terminal because we're still building the profile. We can get that same information by querying the API using EKS control. We'll let that keep going.
I'd be curious to know, behind the scenes, whatever you can divulge, but like, what is the Fargate profile? What's all that's happening in that creation?
Well, we're actually adding some logic to the control plane, and we're using that logic to mutate the pod definition for anything that gets launched in that namespace. So instead of having a controller running on your data plane, which we could totally do, but the problem with that is it's a chicken and egg scenario. For us to do that, you'd have to have a data plane, right? So if we were going to run a controller that does all of this logic, then you'd have to have a data plane to launch it onto. So then you're running instances again. So we didn't want you to have to do that. So we bake this logic into the control plane, and that way we can edit on the fly the pod definition and tell it to launch out on the Fargate instead. So anything that comes into that namespace is going to go out to Fargate. Nice. Let's check on our progress real quick. Oh yeah, compute. And we're active. So we're good to go. Okay, so just like yesterday, we deployed pods, but this time what we're going to do is nothing different. We're going to deploy pods again. These pods are coming from, maybe we have to wait for EKS control to be active. I'm going to go ahead and launch these. Oh, do I have this running?
Probably from yesterday.
Oh yes, let's delete. Let's delete the deployment. And
yeah, for context, yesterday we deployed services using the ALB ingress controller, and we're deploying these same services just on top of Fargate now. So
correct. Oh,
double F.
I know. Okay, delete. Oh, that's why that's funny. That's why this was probably taking so long, is because it was moving those pods over to Fargate. So I wanted to go a little bit more step by step, but that was actually because it was running. I didn't even realize it. I was waiting on those pods to actually move. Okay, so let's just double check that. Let's cube control get pods dash capital A for all namespaces. By the way, if you don't know that, that's a cool little shortcut. You can also do dash dash all dash namespaces. And we'll just scroll up, and all of our pods you can see are running cube system, my nginx. I think I should go ahead and delete the ALB ingress controller also, just from yesterday. And let's cube control delete dash delete namespace my nginx while we're at it. I think that was from the day before. While we're waiting on that,
There was just a question around what is an ALB, and it's funny. We tend to talk in acronyms because we know AWS. We've been working with it for so long, you and I, Brent, that we will say, I said it. I was guilty of it. I say ALB. So yes, ALB, application load balancer. Generally, everything in AWS is abbreviated into an acronym of some sort. So that's what we were doing. The application load balancer ingress controller.
Yeah, so in the history of load balancers at AWS, we started off with what is now lovingly referred to as the classic load balancer, sometimes CLB, formerly ELB, and then the next thing to get released was the application load balancer ALB, which focuses on layer 7 of load balancing. Then there's also NLB for network load balancing, layer 4. So those are the two, the NLB and the ALB are the two current load balancers, with Classic still being available as the both layer 7 and 4 solution that's still around. So okay, I think I've cleaned up enough. Now let's go ahead and redeploy. So we're kube control applying. And what we did was we built a namespace, a deployment, and a service. And we can actually just watch this rollout to wait for our pods to come available. And this is going to take a few minutes, so we'll just sit here and answer any questions, or we could talk about.
Well, let's talk about Fargate, because
yeah.
Why is this taking a few minutes as compared to, when you already have pods, or I'm sorry, instances, worker nodes available in your cluster? The scheduling is pretty quick because they're already there. It can schedule those pods to those instances. However, With Fargate, you have to think it's spinning up a virtual machine that's going to run your pods. For each pod, it's a one-to-one match, by the way. So when you deploy a pod, your pod could be one container or multiple containers defined, and those are being launched onto that one virtual machine that's coming up. And as you can see, it was actually pretty quick. It wasn't even a few minutes.
No, it wasn't a few minutes. It was a few seconds, which I think is awesome because, like you're saying, Adam, we're bringing up virtual machines. We're launching your containers inside of them. You know, we're mapping ENIs to them. We're doing all kinds of stuff that is sort of pre-done for you when you're launching onto you know, managed nodes or your bring your own EC2 instances. But what you get with that is really cool. If you're security minded, one thing that you get that I love is that you get isolation. So you know, everyone likes to talk about container security. Well, we're wrapping your container in a VM, and at that point, then you know, think about if someone were to break out of the container or break out of the pod, what would they have access to? None of your other pods, right? Because there's a unique VM for every single pod that we bring up on Fargate. So that's really cool. I love that. And then, you know, the unique ENI is another, I think, strong advantage here because in the worker node space, the managed workers and the EC2 instances, you're sharing an ENI, and you get the cool like IP, you know, VPC level IP addressing, but we're packing those onto ENIs and then allocating additional ENIs to your workers as needed. So in a lot of respects, you're still sharing an ENI, but in Fargate, you're not. You're getting a dedicated ENI to that pod.
Yeah.
Okay, let's continue forward. So we saw a rollout. It was successful in a few seconds. Now, what I want you to notice is what we see with kube controlled get nodes. This is, I think, my favorite because basically what we've done is every Fargate pod is a node as far as EKS is concerned. So we can manage each of these, you know, just like we would manage any other node. So you can see the difference, though. Sort of the breaking point is my 3 managed nodes that we looked at earlier that had been around for 2 days. They're still here, and then I have my 2 minutes ago nodes that came up, and they all have unique addresses. They all have unique host names. They all have unique IPs and capabilities to be able to handle traffic.
And I have to say, chat today is just aggressive on the question marks. There's just a lot of question marks that are coming in hot right now. So
nice.
I don't know. There was a 169.255.169.254. I assume that that's relating to the metadata endpoint. Maybe there's a question around that. Do you have that anywhere in here?
I don't recognize it, so I don't know what it is, but feel free to expand on that if there's a question. There are a lot of question marks, so I do feel like there's a question, but expand on that and we'll get to it.
Absolutely.
Okay, so the next thing we have our service up and running. We just can't get any traffic into it right now because we still don't have ingress. So just like yesterday, we need to build ingress. What we're going to do is create an IAM service account, and let's run it, and then we'll talk through the options. So this is building a service account for us. We're naming it ALB ingress controller, and we're tying it to the namespace 2048 game in our cluster, EKS workshop, EKS control. And we're attaching a policy ARN that is that unique address that we saw a minute ago. The -- approve says, automatically approve this. Don't wait. Don't do it in dry run mode. If you don't want, obviously, it's good to do this in dry run mode once if you've never done it. And then override existing service accounts says exactly, what it's going to do. It's going to replace any existing service accounts with a new one. So basically what we've done is we've created a service account that is allowed through IAM to provision ALBs for us.
And, just to, if you don't mind, Brent, just to talk a little more about that. So, when you're talking like native AWS services, generally they can talk to each other through IAM. It's all native. Now, Kubernetes being an open source project that's managed through EKS, it's still something that's being built outside of the native AWS ecosystem. So the way
native Kubernetes ecosystem.
Yes, thank you. Exactly. So the way to integrate the Kubernetes with IAM and to have those service accounts attached to your pods is through that OIDC provider. So Kubernetes talks to the OIDC provider, which talks to IAM, which then tells that pod what level of access it has. So it's giving you that native experience in AWS with attaching roles to your pods just through that mechanism. So I just wanted to talk a little bit about that.
Thank you for walking through that, because prior to the OIDC provider and URSA, IAM roles for service accounts.
Yeah.
Prior to those existing, what you would have to do is attach a policy to the node group. And so that means, any EC2 node that is running, or any pod running on that EC2 node would be able to grab, those temporary credentials and have that kind of access to the rest of your cloud account. And that's not something that you want. And there were some workarounds that existed that you could deploy, but this one is so much more straightforward and clean that it's definitely worth exploring if you haven't set it up already. Check it out. Okay, so you can get service account information. I did that right here, get service account for the ALB ingress controller, and you can see the link to the ARN and all that stuff. So yeah, next thing we're going to do is we're going to create an RBAC role, and this is basically going to grant permission to the service account that we just created, and this is Kubernetes permission. So we have our service account configured. We have our cluster role binding unchanged because I didn't delete it yesterday, and then configured for the ALB ingress controller here. I didn't talk through this sed right here, so let's actually mention that. What we're doing here is we're curling, and you'll see this throughout this particular chapter. We're curling from the official Kubernetes SIG GitHub repo. So this isn't anything we've written. This isn't a black box or anything like that. This is the official example for how to deploy this 2048 game, and using the ALB ingress controller. And we're pulling it straight out of the documentation. And the one edit that we're making is where they have namespace as cube system. We're replacing that with namespace as 2048 game. So if we kube control get pod -in 2048 game, what we find is the 2048 deployment, and this is granting permission. So yeah, we would have to pull up the permission to see that. I was hoping to see the controller running. Oops. Oh, Helm. Ooh, let's see if I have Helm installed or Helm ready to go. I don't. This is funny. So let's go and follow the instructions. If Helm is not found, see installing Helm for instructions.
Nice reference there. That's very much appreciated.
Exactly. Okay, so let's install the Helm CLI real quick. We don't have to do this whole chapter. This is going to be super quick. We'll test it. Helm version, great. We're going to add the stable repo just because it's good to have a Helm repo added, and the stable repo is stable. And if we want to test to see that the stable repo is referenceable, Helm search shows us that, yes, we can find things in the stable repo. So we're good to go. This is optional. It's bash completion. When that's available, I like adding it. So you could do that, or you could skip it. Either way. Okay, so we've installed Helm. So we'll go back to our instructions, and let's just double check. Now we have Helm version with output, so we know we're good to go. So now we're going to add the incubator repository, Kubernetes charts incubator. And we're going to, let's step through this a command at a time. We're going to build an environment variable that knows what our VPC is. So if we just run this command by itself, this is an AWS CLI command. So we're just querying the AWS API, and we're describing our cluster. We're querying for cluster.resources VPC config.vpcid, and we're outputting that in text format. So we're basically getting back the VPC that our EKS cluster lives in. So let's actually set that as a variable now. Echo $VPC ID. And you see our VPC ID is now in our environment. And the next thing we're going to do is we're going to Helm install the 2048 game. And we're going to, what are the things to point out here? We're going to set the AWS VPC ID, set the region, set the image tag to be the correct ingress version. We've already created the RBAC. Here's the service count name that we're going to use in the cluster name. So it's all pretty straightforward. We'll just paste that.
And for those who we went over Helm in one of our previous streams, but something to point out, Brent, if you just go up to the what you pasted there. Mm-hmm. So just things like image.tag. This was a variable that's set in the Helm chart. Yeah, so this is just a value we're overriding with our proper version, our VPC ID. So it's just cool to see this is a generic Helm chart that we're able to pass our personal values to, for our environment.
Good point. So, yeah, you don't have to download the chart, edit values.yaml, and substitute in any of your own stuff. You can sort of retemplate it on the fly by just passing -- set and then the YAML positioning of the key and the value, the new value that you want it to have. Okay. So let's watch our rollout again. It is successfully rolled out. And let's get pods. And we see the ALB ingress controller is now running. That's what I was looking for a minute ago. I forgot that we hadn't actually run the ingress controller yet. Now, with that, what's going to happen? So we now need to set up ingress. So what we're going to do here is we're going to curl the ingress definition straight out of the documentation, and we're going to substitute metadata annotations target type, and we're going to set that to IP. So this is a good time to point out YQ. I love this utility. You're probably familiar with JQ. What does JQ do, Adam?
So that's a JSON manipulator, pretty printing. It's wonderful.
Yeah, you can pretty print, you can syntax check, and all that stuff. But then YQ is the same thing, but for YAML. So we're going to grab this. We're going to paste. And YQ, my YQ is actually a Docker image. That's another thing that I find cool. It's an alias to a Docker image. So it didn't exist yet. So I went ahead and pulled it down, and then it ran it. And you can see that our ingress is now created. So we could go and check the console. Let's do that real quick. Services, EC2, open in a new tab. And we should find a load balancer coming up. Load balancer, oops. I am very, very satisfied.
Always looking for feedback. It's that internet connection from Texas to Ohio.
I know, right?
Feedback loop there.
All right, so we're in a state of provisioning, and you see in the DNS name is 2048 game. So we know that this is the load balancer for us. So this is being provisioned by the ALB ingress controller. All right, the other thing to note here is the target groups. So let's take a look real quick at the listeners, view and edit the rules for port 80. And then you see that if path is / anything, forward to this target group. So this is another thing the ingress controller built for us, is this target group. And what we should find, I'll just wait, I won't spoil it. So the edit, that said edit, is we were setting the target type to IP. And then our targets, you see, note that there's 5, and we have 5 IP addresses. Let's go back and let's check. Let's do kube control get nodes. And you see 192.168, 126.140. There's 126.140. So our Fargate nodes are directly in the target group. It's not the EC2 instances that's in the target group, it's our Fargate nodes. So I think that's really cool. Let's continue forward.
And that is a really nice piece of when you think about the ingress controller managing all of that on your behalf. That's really nice, getting it into the target group, ensuring your pods are healthy. Then they get, they're in the target group. That's all done for you with that controller. It's very nice.
Exactly. It's all directly integrated. It all is just managed for you. So you can see that we now have our 2048 game and it's up and running and we can access it. So this is basically where the workshop stops. And the next step is the cleanup. I actually want to do one last thing. You have any ideas, Adam?
Oh, I'm so happy you let me. You gave me the opportunity to announce this. We're gonna kill the node group that has EC2 instances, right? The managed node group. So it's only Fargate. Is that right?
Exactly. So
yes.
I love deleting infrastructure, like we were saying. So kube control get nodes. Let's get rid of these 3 nodes, and we'll see then if the 2048 game is still perfectly accessible. So EKS control get node groups -- cluster EKS workshop EKS control. So my node group is named node group. So EKS control delete node group -- name node group. I bet I need -- cluster EKS workshop EKS control. Wow. So all that's really doing is it's sending a CloudFormation delete. Let's go over to CloudFormation real quick. CloudFormation.
And so the idea here is to prove that we're not just running these on some EC2 nodes in our node group and we're just, smoke and mirrors here.
Exactly, yeah. So this delete's in progress. And while it's deleting, let's get nodes. And you see scheduling is disabled. So these are cordoned, likely drained also, but there shouldn't have been anything running on them. And I don't know if I should watch or if they'll just go away on their own. I don't know if watch will show me that they've gone away either. I've never watched for something to go away.
It's working on it.
Yeah. Well, while we're at it, let's just check EC2 running instances.
Man, that, double fiber, dual gigabit connection seems to be doing you a disservice today,
right?
Brent.
Yeah, it's all this live streaming.
Yeah, I'm just kidding.
Luckily, so I had some work being done by the neighbor in the side yard, and he cut my fiber the other day. So I now have a temporary laying across the road and up my yard.
Nice.
But I assume it's just as fast. Okay, so the EC2 nodes are gone. So if we get nodes, all my worker nodes are gone, and I'm only left with Fargate nodes. And if we go back here to the 2048 game, we'll just hit reload, and sure enough, I can sit here and keep playing 2048.
That's awesome.
So serverless containers. I love it.
Yeah, think about this. In this setup right now, you as an operator of a Kubernetes cluster, what are you managing? You can see some side. Green screen's failing me right now. Uh-oh. Well, anyway, it's all good.
Yeah, it's all good. So what am I managing? I'm only managing, well, there's a managed control plane that I'm sending, my commands into and stuff like that. And then I'm, that's it. I mean, my pods, my containers, whatever is inside of those. I don't have to worry about any of the compute. I don't have to worry about patching, updating, vulnerabilities, what else, what software is installed on these things. Like, none of that. I feel better already.
Right. Like, as we've done this, Brent, we have done this. We've managed clusters. We've managed the worker nodes. Listen, there's going to be situations where you have to run your own worker nodes for whatever reason. I get that. But totally. In the situations where you don't have to, think about the management of this. Okay, I need to upgrade my Kubernetes cluster. Okay, so we issue an upgrade. Now, assuming everything is compatible with all of our deployments and everything, all we have to do is restart our Fargate tasks.
Yeah.
And
you can do a rollout restart, or you could just wait for your next deploy. That's what I do. If you're a typical startup or microservice organization, you're probably doing many deploys a day. So, upgrade that control plane behind the scenes, and then, on the very next deploy, your Fargate tasks are all going to get rolled to the next version anyway, and you didn't have to do anything. So this is definitely, this is game changing. I love it. So I highly recommend it. If you have any questions about Fargate or EKS or just running containers on AWS, throw them on Twitter to Brent Contained or Real Adam J. Keller. Join us tomorrow for a day of talking about containers. We're going to have all kinds of people on talking about just the best ways to run containers on AWS. We're going to have very high level people. We're going to have product people. They're going to be talking about the future. They're going to be talking about the current latest state of affairs. There's just going to be all kinds of good information. Adam and I are going to be joining you halfway through, and we'll be there to answer your questions live if you have any. So definitely prep them along the way. And yeah, that's it.
That's it. Yeah. Thank you, everybody, for joining. We will see you tomorrow. And then after that, we'll see you next week, Monday.
Awesome.